Okay, so let's start. So, in the previous class, we have discussed about what? We have seen the practical about GRE. Okay, so now just 5 minutes for the GRE here again. So, GRE provides what? GRE provides only encapsulation. It would provide what only? Encapsulation. Into this, there is a no security. What is there? We don't have any security because there is a no encryption, there is a no hash, and there is a no authentication. Nothing. We don't have any single cryptographic method into this. Okay. So encapsulation, how many bytes of header it would add totally? It would add total 24 like bytes header. Okay. So in the previously, this was a topology actually. Like let's consider this is our site A, this is the site B, and then in between we have ISP. So this is connected like this, and this is about 11.1, and consider this is we have 15.1. Now, this is one tunnel, and this is the tunnel IP that is about 192.160.1.1 here, and this is about 1.2. This is LAN A, and this is LAN B here. So this is about 1.1.1.1, and this is about 2.2.2.2. Okay. In the routing table, we have to define like about like static route. In the static route, we have to define 2.2.0 network /24, how to reach via 192.160.1.2, right? And on the other side, we have to define a default route in the routing table. We have to define how to reach to the one network here. The like is 1.1.1.0/24, and it's via 192.160.1. Clear? Okay. So let's consider from here. I'm just trying to ping with the 2.2.2.2 as a source of 1.1.1.1. Okay. So now tell me how the packet would be looks like. Okay. So let's consider this is that packet here. So in this, what are the things would be added? So first of all, this is about ICMP. This is about what? ICMP here. 1 second. First of all, source IP, then destination IP, and then about protocol, and then type and code here. So now, what would be my source IP from here? The source IP would be, so from here, okay, I'm just going with the which concept? I'm just doing here ping with as a 1.1.1. I'll like 2.2 from the what? 1.1.1 here. So first of all, source IP, destination IP, protocol, and then type and code here. Okay. So what would be the source IP? Destination 2.2.2. Protocol would be, what is the protocol number? What is the protocol number? 1. What would be the type? Type. So type, tell me the type number. 08, and code would be 00. Okay. So this is the normal packet here. So this is about ICMP. So, but right now we are using GRE on this. What we are using here? GRE. And on this side, in the interface, we have mentioned interface tunnel 0, IP address 192.160.1.1. And what is the tunnel source? Tunnel source is 11.1. And what would be the tunnel destination? 15.1 here. On the another end, we have mentioned this is for the another end here. Tunnel interface 0 or 1, whatever. This is .2. This is 15.1. And this is the 11.1. So this is the configuration here. Now, when I'm using GRE, so what happened? It would add your GRE header first. What would be there in the encapsulation? Encapsulation means adding the header. Adding the header here. So this is the concept about what? This is GRE header here. of how many bytes? This is all about 4 bytes. GRE header size would be what? GRE header size would be 4 bytes. But after that, we need an again IP header to route the packets, because routers, how this packet would be routed based on the IP addresses here. So then we have again one more header, that is again source IP and destination IP. So this is about what? Source IP, and this is about here. This is source IP, and this is about destination IP. So this time the question is, so this is outer header here again. This is like one more IP header. One IP header we have inside. This is again IP header we have. Okay. So this is, what is the size of this header here again? 20 bytes here. So what would be the total size here? Total size would be 24 bytes. So the question is, what would be the source IP and destination IP here? The question is, what would be the source IP and destination IP? So when GRE would perform the encapsulation, first of all, it would add the GRE header. After that, this header is known as now outer header. This header is known as outer header, and this header is what? This header is all about inner header. Is that clear? So this is your inner, and this is what? Outer here. So in this, then we have to mention source IP and destination IP. So what would be the source IP into this? Source IP will be not 1.1. The source IP, it would choose it, or it would select it from the tunnel source. Who's my tunnel source? 11.1 here. So it would be 11.1. What would be my destination IP? That is from the destination, that is 15. So this is about what? This header is all about tunnel and points. What exactly this is? This is all about tunnel and points. And what are the endpoints here? So from here, what is the source? 11.1, and what is destination? 15.1. So this is my encapsulation is ready. But the problem is here, there is no. Is that clear? Do you want to make the notes? Please do that. How many of you have practiced GRE? Yes, online plus offline. This also I have not practiced, right? So this is the first time. Yeah, I have given you the task and you have not done it. Okay. Next time onwards, I'll cancel the class. Okay. And I can skip the topics also. Because if you would have the same habit, so how many times I'll cancel the class? So then I'll skip the topic for that specific day. Okay, so last time I have not told you, that's fine. And this is the first time, because this is not the RNS classes now. On the daily basis, you have to perform the task. Okay, so you had even 3 days, and this was just a simple practical. Hardly, I think it takes 5 to 10 minutes, nothing else. So today again, we have some theory part. Okay, so make sure everybody has to finish it. I have already shared the link of the WhatsApp group. I hope you have joined. Okay, so in that group itself, after the completion of your task, you have to share the screenshot of your task with your name. Okay, so this is a daily practice. Okay, again and again, I'll not ask you to do this. So this is a by default now. So whatever the practical I have done it, you have to practice the same, and then you have to share in the drive. Okay. Not drive, sorry, in the WhatsApp. Online guys, I hope everybody has joined the group, right?
Yes, sir. No, sir, I have not got the invite.
Sorry?
I have not got the invite to join the group, sir.
I have shared it on email actually. On the email, I have shared like a link actually. Yesterday, I have sent an email. You have drive, I think do you have drive access?
Yes.
So then definitely it should be there, because I have copied all the email IDs from the drive itself. So you just check your email.
Okay, okay.
Okay, might be you have missed it.
This GRE is route-based VPN also. Same, both are same.
Yes. This is route-based VPN. This is only route-based VPN. Okay. So in GRE flavor, what we are doing it point to point. What we are doing it this one as a point to point. So in the upcoming classes, we have to talk about multi-point. That would be the MGRE. But before that, we would discuss about IPsec because we have to make it secure because this is not secure. So on top of this, now we are going to be deploy IPsec here. So now first we will discuss what exactly the IPsec, how does it works, what are the because we have some negotiation process in IPsec. How does that happen and how that would protect us? Okay. So I think now IPsec would take 7 to 8 classes. I think so. Let's see, depends on you as well.
So for GRE, there is any two lines.
This is just an encapsulation concept here. Okay, nothing else. This is security. In security, for one thing, you have to refer 4, 5, 6, 7 books over here. I have uploaded already books into your drive. Okay, notes and everything is there. Okay, if you have not opened your drive, so that is not my mistake. Okay, everything is in your drive. So just open the books and then start studying from there only. Okay. So GRE is one of the route-based VPN, which would provide just only encapsulation. There is no security into this. In security, you have to prefer multiple books. If I'll talk about now IPsec, for IPsec, at least there is 6 to 7 books you have to refer. One, because IPsec has like almost 10 to 12 different features. One feature explanation is good into this book. Another feature explanation is good into another book. So you have to refer multiple books here. Okay. And along with that, you have to refer RFCs. Have you gone through ever RFCs? You know what is RFC? Right? So RFC, you have to start it now. If you want to really dig the security. Okay. Reference for comments. Clear? So this is one of the wired captures I have. I'll show you. This is the one of the previous captures. So here. Now, so say this is the same ICMP packet. Okay, we have captured in the last class, and you can see we have ICMP, then we have header header. This is the private 10.1.1.1 and 10.2.2.1. Right now, in the diagram, I have mentioned it as a what? 1.1.1.1, and this is as a 2.2.2.2 here. This is GRE header, okay, and this is the outer IP header. What is the source here? 11.1, and what is the destination? So how many bytes of header it's adding? It's adding 24 bytes of. Clear? But this is not secure. The reason because we don't have any security on that. There is no encryption, no hashing, and no authentication. Clear? Okay. So this is first and the basic route-based VPN here, which is all about GRE. Okay, and GRE, this is the first of the flavor. Next protocol we have now, IPsec. So what does it mean? Internet Protocol Security. So what is IPsec actually? Okay, like IPsec is a suite of the protocol. What is this? This is one suite of the protocol here. What exactly the suite? Suite means it's kind of box of the protocol. This is the one of the suite of protocols. Okay, in this we have a different type of protocol type, like protocol 1, protocol 2, protocol 3. So this is one of the box here. Same in the future, we would talk about SSL. In the future also, again, there would be what? SSL. That is again the same sort of the protocol here, where again we have multiple like protocols inside that, 1, 2, and 3. This is just 3 is just a number. Okay, so it means what? IPsec and SSL is the kind of what? Suite of the protocols here, and inside that we have multiple protocols. Okay, so let's talk about IPsec. There's no discussion about SSL because SSL is not now. That would be after 15 days. So now I'm talking about here what? IPsec here. So what exactly IPsec, the source of the protocol? We have the combination of the 3 concepts here. The first is IKE, second ESP, and third is AH. Note it down. IKE. IKE means Internet Key Exchange. Okay. IKE means Internet Key Exchange. Okay. IKE is further divided into how many parts? 2 parts. IKv1 and IKv2. Just mention up to here only. That's it. IKE now is divided into how many versions? 2 versions. Further is version 1 and then version 2. Version 2 would be the last class of your VPN. Okay, this would be the last class. Second last and the last. Last 2 classes all about IKv2. Now, this is clear. Up to here, guys, everybody has done. Now, so we are talking about, as like I have started, IPsec is what? IPsec is the collection of the protocols here. So the one protocol we have about IKE. Okay, it has 2 versions. The first one is IKv1 and the second is IKv2 here. IKv1 and then second is about IKv. Okay, along with that, we have 2 more protocols. One is ESP and second is AH. ESP and AH. ESP would provide 2 things, encryption plus hashing. It will provide 2 concepts. One is encryption and second is hashing. And authentication header means AH would provide only what? Hashing. It would provide only what? And we have already discussed what is encryption and what is hashing, right? Earlier, we have already discussed in the cryptographic methods, what is encryption, what is hash, what is authentication, and what is Diffie. Clear? So these things would be needed now. IKE. So not IKv2 right now. So we are going to be talk about what? First of all, IKE. Okay. As per IKv1, let's talk about here. I'm going to be use the concept about IKv1. As per IKv1, you know TCP. In the TCP, we have what? 3-way handshake. The first packet is SYN plus ACK, and then acknowledgement. Same here, we have handshake concept. What we have in IK, we have handshake. But that concept, we don't call it as a handshake, we say it as a message exchange. What we call it as a message exchange here. So that message exchange, or you can say further, IKV1 is divided into two parts. The one is phase 1 and second is phase 2. This is known as phase 1 and this concept is known as phase. This concept is known as phase 2 here. In the phase 1, we have two modes. One is main mode, or we can use it. We have one option is main mode and second option we have aggressive. Here in the phase 2, we have only one option, which is about which mode? Kindly note it down. The first phase 1 is main mode or aggressive. And the second one, we have only one option, which is quick mode. Really, IPsec is very interesting. And yes, one more thing, one of the major and the most important topic for interviews. Recently, almost 20 students has appeared for the checkpoint and the Barracuda. Okay, and they have asked about the four things only: TCP, DNS, DHCP, IPsec, and SSL. That's it. Okay, but yes, SSL they have digged, because in SSL we have handshake concept. Okay, we have some concept about their pre-master key, master key, and along with that certificates. Okay, so all VPNs are important from the interview perspective. Okay, along with this, if you are doing something routing and switching or something, I'll ask you to stop it for time being. Okay, focus here on the VPN, because this is the backbone and the major topic of the security, first of all, and second, this is VPN completed means 50% of your interview preparation is completed. Okay, so just try to focus on this. Okay, or else you can ask your seniors. Recently, Devraj, Pankaj, okay, Faisal, okay, these 4-5 students got placed in checkpoint and some students got placed in this one, Barracuda. Okay, so these are the only questions they're asking. Okay, so no BGP, MPLS and all this is not needed, because you guys are just freshers. So no need to focus on those topics. Focus on these core topics of security. Okay, so now main mode or aggressive, and second we have quick mode here. So the first, there would be two combination. The combination is what? In the first mode, if I'm using main mode, then quick, and if I'm using aggressive, then along with. So we have how many combinations? This is not an end. This is, I'm saying, or main mode, or you have option for aggressive. So if I'm using main mode, so the combination is main plus quick, and second combination is aggressive plus quick mode here. So the first combination, if I'll talk about here, which is main mode plus quick mode here. This is the first combination. Okay, and here in quick main mode, we are going to be, when the message exchange would be there, in the main mode, we are going to be exchange how many messages? 6. And in the quick mode, 3. So total, how many messages exchanged? 9. Like in TCP, total we have 3. And here we have total, how many? 6. Second combination is, if I'm talking about aggressive mode plus quick mode here. Aggressive plus quick. So again, in quick, how many options we have? Option for the 3. So aggressive also has having 3, and plus 3 is equals to how many? 6 messages. So you can say here, I'll mention main mode, how many messages? 6, aggressive mode 3, and quick mode again 3. So the combination now, if you're using main plus quick, total is 9, and if you're using aggressive plus quick, so in total is 6. Main mode and aggressive mode, this is more secure. Okay, and this is less secure. There would be reasons. that we would discuss in the classes now. Okay, so first of all, let's talk about main mode and quick mode concept. Okay, yeah, this is if I'll compare the first combination, this is faster and this is slower. The reason we have 9 messages there and how many messages we have there? 6. So obviously this is the common sense. 6 is the faster one, but yeah, obviously that is less secure. So this is the combination where we need less security. Okay, we can use which mode? This combination, and this is the concepts where we need more. Okay, this concept is over the ISP because ISP is not secure, and this is concept we can use within LAN, you can say, or within the same enterprise or network. Because when we are sitting inside the house, we are secure. Okay, so but we are not totally secure. Fully, it's not okay. So, but still, okay. When we are talking about outside as compared to outside, inner is what? Secure. Inner concept is what? Secure, but not fully secure. These are the 4 major differences. I hope you have mentioned it. Okay. Now, main mode plus quick mode here. So this is the phase 1. So first of all, once your phase 1 would be up, then only we can think about or we can move towards the phase 2. In case if your phase 1 itself is what? The phase 1 itself is down because of some reasons. Okay, so this is also would be again down. So there is a no possibility. So first we have to make sure the phase 1 must be up. Okay, after that only we can think about the phase 2 because phase 2 is totally depends on what? Dependent on the phase 1. If phase 1 itself is down, we cannot think about the phase 2. Once phase 1 would be up by default, the default I'm talking about, the default timer is 24 hours. So it would be up for how many hours? 24 hours, and in seconds, this is the seconds over. Phase 1, phase 2, if I'll talk about the default one, this is 1 hour. What are the timing here? 1 hour, and in seconds, it would be 1300 seconds. Can you note it down? These are the timers. When we exchange these 9 messages, okay, so we have to use, there would be one default protocol that is ISA CAM. This is the protocol over. Internet Security Association Key Management Protocol. This is the protocol, Internet Security Association and Key Management Protocol. Clear? It would use your protocol UDP. UDP protocol number 17, and it would use its port number 500. Which port number? 500. Clear? So timer is about 24 hours. This is about 1 hour, and this is totally dependent on the phase 1 here. So what exactly the phase 1 would perform is the main concept. The main, if I'll ask exactly why we need a phase 1. For what? Authentication. Note it down. The phase 1 is mainly we use for what? Authentication. This is the main purpose for the phase 1. This is not the only purpose. This is the main purpose of phase 1, which is authentication. Authentication, and another concept is key exchange. Second concept is what? Key exchange. Phase 2 mainly we use for what? Actual data transfer. Actual data transfer, and this is the reason this tunnel is also known as data tunnel. This tunnel is known as data tunnel. Okay, where what would be their encryption? Encryption plus hashing. The major function is what? Encryption and hashing over. And then we have optional is what? Key exchange. This is what? This is about the optional. What happened? All good? Clear? So this is the major and the important things about the phase 1 and phase 2 here. So the phase 1, first we are going to be talk about its first combination, and what we can say we are going to be discuss about the how many messages here? 9 messages. Okay, so let's start with the first concept. The first concept is here.
Sir, in phase 2, the port number and we use UDP and
Will
number.
remain same. Okay, as a cam, port number will remain same. Same protocol, like protocol is 17 and UDP 500.
And
Okay, now this is for as a cam. Okay, but in phase 2, we have two more optional protocol here, which is AH plus ESP. It's about what? AH and ASP. So if I'm using ASP, so it would provide encryption plus hashing. And if I'm using AH, so it would provide only hashing. Okay, that's it. And for ESP, which protocol we have? Protocol number 50. And for AH, which protocol number we have? 51. But for ISAC CAM headers, for ISAC CAM, this one and this one will remain same. So what is the AH protocol number? 51. And what is the ESP protocol number? 50. Like TCP protocol number? 6. But TCP has a further so many services. That's the reason we have different ports. Like Telnet is a different service, SSH is different, SCTP is different, SCTPS is different. That's the reason we have port number here. So in this, AH is about 51 and ESP is just 50. Now, let's talk about for here IPsec, IKV1, and the first combination I'm going to discuss here, the main mode plus quick. Main mode plus quick. Kindly note down. So this is the concept now where I'm going to be starting. Clear or not? Now, let's start with the main mode first. So as you know, in the main mode, how many messages would be there? 6. And in quick mode, 3. So total, how many messages? 9. So let's consider these are the two sites which is connected over the internet here. Okay, over the internet here. And we have to make sure what should be there. For any kind of VPN, if you want to configure, the first thing what we have to make sure what should be there? Reachability. So this is 11.1 and this is about what? 15.1. I'm able to ping from 11.1 to 15.1 and 15 to 11 here. Now, I'm going to be configure a VPN and in that I'm going to be use what? IPsec, because IPsec would provide me 3 things: encryption plus hashing plus authentication and some other features also. But these are the 3 main and the major features, sir. So let's consider, as we have discussed earlier, like during the cryptographic methods, in encryption, if I'm using here 3-, in hash, if I'm using here MD5, and in authentication, if I'm using PSK, we have to use same things on the another side. That must be same. In encryption also, it should be 3-, so 3-, MD5, so MD5, and PSK, and after that even key also must be same. Okay, so now for on the both the sides, where I'm going to configure VPN here, so both the sides has to negotiate with each other on these parameters. Okay, and for that we have what? Message exchange. Let's consider, for example, it's you and you are just going some, like you are outside some event or something, and you want to talk with another person, and another person also want to talk to you, but there is no communication has been started. So there is a possibility you would start the communication, or there is a possibility another guy or candidate would start the communication. Means out of these two, one would be initiator and another would be responder. So we would consider this is what? Initiator. Who's this? Initiator. And this would be what? Responder. Clear? So once it's about initiator, so initiator would send the first message. This is message number 1, and this is from the which side? Initiator side. It's using which protocol? It would use ISA-CAM. Okay. And the first message is all about Haggle. What is that? Haggle. So in the first message, we have so many informations will be there, but this is the first and the basic information. Okay. The first and the basic information would be Haggle. Haggle is what? See, this is one of the initiator. And from here, there is a possibility that this device can use here 3- as a network admin. I have to configure. Let's consider this device is able to support what? This device supports here -3- AES. Another device has just can support it only what? Dash and 3-. So AES is not there. So from here, what? From here, we have to send kind of one proposal. We have to send what? Proposal. In the proposal, there could be the option for the multiple Haggle. Multiple Haggle means, I'll explain now what is Haggle. Haggle means H means hash, A means authentication, D means Diffie-Hellman group, E means encryption, L means lifetime. Please note it down. This is the Haggle concept. Just power on this. Is this done? Hash means hashing, A means authentication, G means Diffie-Hellman group, E means encryption, and L means lifetime. Let's consider you are planning for some outside. Okay, you want to go. Okay. Notice the notes are down. Just note it down. All done. Now, the concept is, let's consider, see, this is you and your friend. You want to go for a movie or something. Let's consider. Okay, you are planning for long, okay, but it's not happening. So today you have decided we have, like, let's consider you are initiator who is initiating for the outing or something, and you have decided, okay, we will watch this particular movie tonight. Okay, there is a multiple shows. The option is 7 p.m., 8 p.m., 10 p.m. These are the 3 shows there. So you would ask your friend, hey, there are the 3 options here. So which timing should I select it? Should I select with, should I go with the 7, 8 or 10? Depends, okay? Because once both the candidate, both of you would negotiate, okay, let's go with the 8 p.m. You are saying I don't have any problem with any timings. I'm sending you kind of what? Proposal. You just choose it and just let me know. Okay, and you have to choose which one? Anyone here. So that is your this is your criteria on what basis you are choosing it. Might be you would choose 7 p.m. You would be back early, or might be you would choose 10 p.m. Okay, we will go in the late night. There won't be any traffic and all. Because if it's 7 p.m. show, so we have to start from home at 5 p.m. because it would take 2 hours to reach the destination here. And but 10 p.m. you have decided late night, there won't be any traffic or something. It would take just 15 minutes from the one side, right? So he has some criterias, might be okay. So same thing. Haggle is one of the concept which we are going to be exchanging to which message here? Message number 1. So initiator would send a proposal. Ki, I do support this Haggle here. This Haggle means here, this first message we have to configure manually. There would be command. No need to write them right now, just see. The command is crypto ISACamp policy 10. Policy just this is one policy. 10 is just a number of the policies. It's in a wide range. Okay, so out of that you can select anything. Let's consider I'll choose 1 here. So in this, first of all, I'll configure as per Haggle. Hashing, I do support MD5. Second, about authentication, pre-share. What is that? Pre-share. Encryption, 3 dash, and then about what is hashing, authentication done. Hashing is done, authentication done, Diffie-Hellman. So which group is there? Let's consider 2. Lifetime, I'm going to use the default one. And what is the default lifetime? 86400, which is 24 hours, but we can change it. Let's consider I'm going with the first combination. So this is my first policy. Second policy, I'll create it, crypto ISACamp policy 10. This is about 2. Encryption, dash, earlier it was 3 dash, now I'm using what? Dash, hashing, SHA, group 2, and then authentication, pre-share, and exit. So this is the which policy? Policy number 2. One more option I'll create it, crypto ISACamp policy 3. Encryption, AES, hashing, MD5, group 5, authentication. Let's consider this time I'm using pre-share and exit. So how many options do we have? 3. So in a Haggle, so it would use which message actually? This is the timer. Okay. Now, so these are the 3 options we have. So if we are not using any lifetime command here, so it means what is the timer here? Timer is default, and default one is what? 24 hours here. So now when we are sending the first message, so in the first message, which protocol would be there? It would use ISACamp. Is used what? ISACamp. In that we are sending 3 proposals. What we are sending? 3 proposals. This proposal concept is known as security association, SAs. What it call it? SAs. So this is my SA1. This is my SA2, and this is my SA3. So SA means security association. Note it down. So security association is equal to Haggle, and Haggle is what? Like the combination of the cryptographic methods here. So can we configure more than one association? Yes, we can. Like multiple timings, okay? 7 p.m., 8 p.m., 9 p.m., 10 p.m. shows are there, okay? So multiple options we have. Out of that, we have to choose one. Lifetime, we can change it, but right now we are going with the default one. At least today we will try to finish first phase. Okay. Try to have one strong coffee before morning class. Okay. If you are a tea or coffee lover. Okay. Because morning batches are always like this. Now see. Next is, just try to understand. This is ISACamp is a protocol which would carry my all the proposal from initiator to responder. ISACamp use which protocol? Which protocol? 17. Okay. And which port number? The port number would be 5. Okay. Now, in this, they would send SA1, Security Association 1, the combination, whatever you have mentioned in the ISACamp policies. Security Association 2, and then Security Association. So it would carry how many information? 3 informations. Inside that, we have already decided what exactly it's there. In the first one, it's about MD5 pre-share 3- group 1. Let's consider in short, I'll mention here. This is MD5. Then second option, this is MD5. The next option we have 3-, then we have PSK, and then we have group 2. In second, it's about SHA, then we have dash, group 2, and PSK. And the third is about AES, and about here MD5, then group 5, and let's consider PSK. So these are the 3 proposals. Okay, and that combination, okay, this Haggle concept is known as security association. Is that clear or not? So when as an initiator is sending this proposal, it would use ISACamp. It would use what? ISACamp. ISACamp, we have one header concept. Like we have TCP header, we have UDP header. Same if we are using ISACamp, so we have always headers. And ISACamp would carry this information inside the header. That information would be inside the header. So ISACamp is not having only this information. It has a different other informations also. So into that, so this is one of that. This is one of that. And the second one is what? Initiator SPI. Security Parameter Index. Another is responder SPI. Who is the responder? Another side is a responder. Just kindly note it down. Sorry?
You can repeat again.
SPI, Security Parameter Index. Very small term, but very important. What is initiator SPI? So see, initiator SPI, second is responder SPIs, and after that there would be SAs. What are the SAs? These are the SAs. So I'll show you just one sample of ISACamp header. Okay, just 1 second. This is so how it looks like, and where would be this kind of information. So total how many messages? As we discussed, 9 messages. So this first 6 messages is all about main mode. 1, 2, 3, 4, 5, and 6. 7, 8, and 9 is about quick mode. Total is 9 messages. Let's open first message. So which protocol it's using? ISACamp. This is UDP protocol number 17, and port number is what? 500 and 500. This is Isaac-Amp header looks like this. So the first option is initiator SPI, and second is responder SPI. Clear? Inside that next payload concept, we have what? Security associations. So how many security associations we have? I have mentioned on the notepad, 3 options. How many options there? 3. It can be more than that also, and it could be 1 also. That depends. And it's, if you don't want to mention, no problem. Predefined, like in the routers, we have default security associations also. Let's consider you have not configured security association and you have initiated the message. So they would use default one. Default depends on the router, which kind of router you are using it. Okay. So security association we have discussed, which is all about what? Haggle. What is all about? Haggle here. Second, I'll just show you this one here. This is how it would be looks like. Kind of what? Proposal. This is overall I'm showing it. Once we will start the IPsec configuration, again, we would capture that. But right now I just want to show you. Okay. So can you see? This is the option. One is dash MD5, Diffie-Hellman group, pre-shared, lifetime in seconds, and what is the default timer? 8640. Okay, so this is the one. This is my second payload. Sorry, second security combination. This is third, and this is fourth. Can you see? 4, 3, sorry, 2, and this is 1. So if I'll close all these, so how many options? 1, 2, 3, 4. So it means when I have done the practical last time, how many policies, Isaac-Amp policies I have created, or how many essays I have created? 4. Clear or not? Now, let's back to the initiated IP. So we have option about what? So now you can see in Isaac-Amp header, we have so many informations there. So right now, I'm just going to be use only 2 informations. One is essays, which is about Haggle, and second, we would talk about only SPI, which is security parameter index. So now we have 2 concepts here. One is initiator SPI, and second, we have responder SPI here. So this is all these things are happening into what? Negotiation. And still we are into which phase, which message? Right now, still we are talking about the message number 1. So first, one thing is essays, and second is initiator SPI, and second is responder SPI. The question is how initiator would calculate, okay, SPI. Can you note it down? How it would calculate SPI. So it would use source IP, destination IP, source port, destination port. Mainly it would use these 4 parameters, and along with that time step. It would use these 4 or 5 parameters here. Okay. And on top of that, it would perform one internal some mathematical formulas, or you can say in short, hash function. It would perform what? Hash functions, and after that, it would generate one SPI value. Clear or not? Now, this is about source IP. Who's the source IP from the initiator? 11.1. Destination IP 15.1. Okay. Source port 500. Destination port 500. Timestamp is, let's consider this is 10. 1 minute and 15 seconds. Timestamp. Even after that, we have millisecond and all those kind of things. Okay. This is the details about what source. But see, as a this is my initiator SPI right now. I have calculated because who I am the initiator. But can I calculate the responder SPI? No, I cannot calculate the responder SPI. Okay, so for that's the reason in the first message, the responder SPI would be who can calculate the responder SPI? Only the responder. So in the second message, or you can say once the responder would share the second message, so then that device would calculate the responder SPI. And with the help of what? Of the help of these parameters. Okay, so on the another end again, what would be the source IP from the another end? 15.1. Destination IP would be 11.1. Source port and destination port would remain same, and the time would be definitely different. Okay, so calculated. So now the another device would calculate the separate value. Okay, so as you can see in the header itself here, what is the responder SPI? Clear or not? Okay, so this initiator SPI value is going to be remain same for next 24 hours, because my first phase is valid for how many hours? 24 hours. In case if you have made it like 2 hours, depends. Initiator SPI lifetime is equal to the lifetime of your phase 1. That depends. Is it 24 hours? Is it 20? Or is it 1 hour? Or is it the 6 hours? Clear? So in the first message, we have discussed about how many things? 3 things. One is security association, and second about mainly SPI. SPI has the 2 things, initiator SPI and responder SPI, and security association you have to configure manually, and that we have configured into this. Clear? Okay, and along with that, we have here what? We have initiator SPI and we have responder SPI. Along with that, there is so many other information, but this is not the time for that. Okay, once we would talk about ISACAMP header, there's a class for the ISACAMP header. So that time we would talk about those things. Any doubt, any questions? What is the size of these SPIs and all? 32-bit. And this is again 32. Yes. Clear? Up to here, online plus physical. Any doubt, any questions?
Sir,
Yes, please.
this 24 hours timer,
Hmm.
so what is the use of it, sir? I didn't get that part.
That is the lifetime of the phase 1. Once they would negotiate, okay, that is the lifetime of the phase 1. Let's consider if we talk about in TCP. Is there any timer for the TCP handshake? No. Until and unless both the devices or any of the device would not initiate FIN packet, that connection is not going to be terminate. Okay, but in IPsec we have phase 1 and phase 2, because in phase 1, okay, as I told you earlier, we are going to be exchange, or this is known as for the 2 main thing. One is for the key exchange, and second is for the authentication here. This key exchange means I'm talking about in the term of the key ring. What is the concept about? Key ring there. Key ring here, actual encryption and hashing would be performed here. Because as I have mentioned, you can just check your notes. I have mentioned the phase 2 we use for the what? Data. You can see if I'll go back here. So this is for what? This is for actual data transfer. This is for the actual encryption and hashing here. So when we would exchange the data, so here on top of that, we need encryption and hashing. For that encryption and hashing, we need the keys. Means so I need a keying material. That keying material would be exchanged within the phase 1. So let's consider they have exchanged the keying material in the phase 1, and this keying material we are using for the encryption and hashing. So for the security purpose, I just want to replace this key exchange after every 24 hours, or might be after every 2 hours, or might be after every 6 hours, because I don't want to use the same concept for the tomorrows. Because if same keying material, if I'll use for the long, might be the hackers, they would try to find out some solution to hack my keying material there. Okay, so for the security purpose, I just want to terminate it and I just want to reinitiate. Okay, so that's the reason we have a lifetime for that. And what is the default lifetime? 24 hours. I hope this is clear now.
Yes, sir. It's like whatever initiator and responder agreed to, that will be maintained till 24 hours, right, sir?
24 hours, correct. Okay, after that, if you want to change anything, you can, but that is the manual process. Usually we don't. They would just exchange the different keys there. Okay, so different keys means key material. Okay, and that we have
Yes, sir.
already discussed how they would generate the key material. Okay, so this is my message number 1 from the where side, from the initiator. This is now responder here. Message 2 is from the where, message 2 is from the responder. Okay, so one more thing, message 1 is the, we have to create it manually because we have to create the headers, like sorry, this ISACAM policies. Let's consider here I have configured one crypto ISACAM policy 1 or whatever the number, that doesn't matter. The number of this, this number is not going to be play any important role into this here. Okay, then let's consider encryption. I'm going to be use 3-. Hashing is about MD5. Authentication, I'm going to be use reshare, and what else? Group I'm going to be used. So this is the only thing I have configured here. Only how many association, how many essays I have configured on the another side? 1. So once the responder would receive the message number 1, and in that we have 3 options, SA1, SA2, SA3. So it's going to be compared with that. Okay, I do support 3-. Is there any 3-? 3- option is there. Okay, so second MD5 is there, MD5 is there. Pre-shared is there. In the pre-share, okay, PSK we have. Group number 2 we have, group number 2 we have. So now let's negotiate. It would reply, hey, this is my selected essays here. So let's going to be start working, or let's communicate with the help of this HA. For example, if there is a I have configured, let's consider this is 5 here. This is what? 5 I have configured. So in that 3- is fine, MD5 is fine, PSK is fine. 3 matters is like 3 parameters are same, but the last parameter is not matching because this is 5 and this is 2. So it's not going to be negotiate on this. Okay, so there would be an error, what? Mismatch of security association. So your phase 1 won't be up. There's no possibility for that. So this is one of the reasons, because in an interview they can ask you what are the reasons, and could you mention any 1 or 2 reasons where the phase 1 won't be up. Okay, so this is the one thing, Haggle itself won't be successful. The reason is we have configured something else on the initiator side and something else on the responder side. So negotiation is not happening. They're not agreeing on the same parameters. That's the reason it won't be up. Is that clear? Okay, so this is, and along with that, it would mention, they would mention here, initiator SPI and responder. So from the another message, initiate, as I told you, initiator IP is going to be remain same. So who's the responder? Responder would again calculate its own SPI. Let's consider 987654321. This is the responder SPI. And how it would calculate source SPI, source IP, destination IP, source port, destination port, and along with that, time stamp. And it would perform some internal hash functions or algorithms, or you can say mathematical formulas. It would use it, and it would calculate one of the responder SPI. Clear? Okay, so this is the responder SPI. And now both the sides has negotiated on which SA. Both the sides has negotiated on the DES SA. Okay, and we have exchanged initiator SPI and responder SPI. So the first and second message we have to generate it manually. Clear? So this is message number 2, and from the which side? From the responder side. Information would remain same. This is just a reply for your proposal. Okay. All done. Now, this is message number 3. Message 3 and message 4. Message 3 and message 4 is automatically. So this is here what they are going to be exchanged here in this. Your Diffie-Hellman exchange concept would be. This is what Diffie-Hellman exchange. And now once your Diffie-Hellman would be exchanged on the both the sides, what would be there? Keying material. What would be there? There would be keying material, which is of the same keying material here, and this would be on the both sides. So this is what we have a key. Okay, or you can say collection of the keys, which is on the both the sides. And that would remain same. And that we have already discussed how actually Diffie-Hellman would be done. So this is just a key exchange. Okay. I'll show you here. This is my first 2 messages. Okay, first note it down. Note it down. Try to make a habit, like some major points you can mention in the class, but proper notes you have to make it from the videos. Because I have so many things which I have to explain. So like this, so I have to extend the timings of the batches. Timings of the batch means overall duration of the batch. This is just a first class. Now, after that, there were so many theoretical things will be there. Okay. So here it's fine, whatever the notes you are making it, try to note down the main head point, okay, main points there. But after that, the videos, whatever I'm providing, then try to make a proper notes from that. Same things, try to study through the some of the Wikipedia from the books, the same dates. Let's consider today when we are talking about the phase 1, phase 2, let's see. So today go back. Now today, so you have made the topic, this one, it's fine. Then try to refer some books on the same dates. Okay, and if you have any doubt, then ask the question next date. Okay, or else you can text in the group. We have almost 300 students, I think, right now in that group here. If I'll be not able to reply, some of your seniors or other students, they also would reply because there 7-8 students are there. They are very active into that groups. Okay, so if you have any query, they would respond for that. Okay. Now, today in the morning, it was raining. Sometime in case of rain would start at 7:30 or 7:45 or something, might be class would happen online. That I hope you can understand. This is some of the scenarios I'm talking about in case. Okay. So today I was about to message in the group, but I was not sure how many of you have joined or not, because yesterday only I have shared the link. Okay. Now, this is key material discussed. Now, after this, see, till now, I have exchanged message number 1, message number 2, message number 3, message number 4. How many messages? 4. First and 2 is all about Haggle. Mainly is about Haggle. 3rd and 4th is about Diffie-Hellman. Now we have key material. So the first 4 messages, guys, they are in the clear. Messages are into the which text here? Clear text. Note it down. Today, so you just note down everything. Okay. Now, I'll show you the 3rd and 4th message. So this is 3rd message. I'll just open it. We have initiated a responder SPI. Now you can see. Last time, the message was about security association. So this time it's about key exchange. Okay, so you can see the keys here. So let's consider this is the key if you would be open to try to this one, but we won't be able to capture whole key here. Can you see dash dash continuing it's showing? Okay, so no idea what is the size of the keys actually. So okay, so this is the concept about what key exchange. So second and third message, we can capture the messages here, but what exactly inside that we won't be able to capture it. So as you can see, the first message, we are able to read everything. So this is now, see, this is header up to where, 1 second, I'll show you, up to here. So this is ISACamp header. Length, you can see, this is what ISACamp header. But after that, we have data. Data means in this header. Okay, see, I hope in OSI model, I'll take you to the OSI model just of for the reference. In OSI model, during the de-encapsulation on layer 2, in the Ethernet header, we have always information about the layer 3, which header we are using it, which route protocol am I going to be used it? Is it IPv4 or is it or IPv6 here? In IP header, we have always information about upper layer, case they are using TCP or UDP or ICMP, what exactly. So lower layer has always the information about the upper layer, correct? Now, this time, this header is having that information in the layer 2 on the layer 2, where is that information? Always into the headers. We have information x080 not for x080 double D over there about the IPv6 and all. Okay, so that information is always present inside the header. So this is my ISACamp header. This is the what? ISACamp header, and this header has always the information about next payload. What exactly? Next payload. So in the ISACamp header, we have a term, and the term is known as next payload. And what is the next payload? Security association. So as you can see, after length, we have next payload is what? Security association. And here we have the information, all the essays, SA 1, 2, 3, 4, 5, 6, whatever you have configured. So means the information I can see. So the information is into which format? Clear text. Same option for the second. So this is also again, how you can say, how, let's consider if I'm asking you, can you say, like, could you tell me, is it the first message or second message? I'm giving you option. Could you tell me, is this first message or is this second message? How would you identify? Can you identify by seeing this information? Responder SPI. So the responder SPI in the first message is always 0. So this is not that information. Okay. And third thing, what is this? Security association. So security association always would be exchanged in the first 2 messages only. So if responder SPI is 0, so this is the first message. If it is having some value, so I mean this is definitely which one? Second. But again, the value would be into the clear text here. The third message, if I'll open here, they have mentioned what is the next payload? Key exchange. And up to length, so we have header, but after that I can see what? Key exchange also. But that is a different thing. That is not the full information, but still information into which format? Clear text is. But if I'll come on the fourth pack, third and fourth is same. But after third and fourth message, we have exchanged keying material. Keying material. In first 2 messages, we have decided which encryption algorithm I'm going to be using. Hashing. Sorry, which encryption algorithm? Dash or 3 dash, whatever. We have decided. So means, can you say, okay, now I'm ready for encryption? Because I know which algorithm I have to use it. And for encryption, I need a keying material, and that also we have exchanged successfully with the help of what? Diffie-Hellman. So can I say 5th packet onwards, all the packets are encrypted? Answer is yes. So now if you would open the 5th packet here, and if you would be able to see up to length, what we have? ISACamp header. But in the next payload, what is the concept here? Identification here. Where the identification? No idea exactly. Because the now data is what? Encrypted. So it means 5th packet onwards. So, okay. Because this is up to 4. This is in the clear text. And now we have which packet? 5th packet or 6th packet. The combination I'm talking means 5th packet onwards. All the packets would be into which format? The reason, because up to here we have already exchanged key material. What is inside the fifth and sixth, that we will discuss now, but the packets are encrypted. So kindly note it down. In interview, they can ask you, okay, which packet onwards encryption would start in I key V1. So that is fifth onwards. Clear? I hope the reason is clear. The question they can ask why, and why first four messages are not encrypted. The reason is even how the first message can be encrypted if they have not decided which algorithm even they are going to be using. And in case in first and second message they have decided, okay. So the question is, okay, let's consider I'm an interviewer, I'm asking, okay, why first and second message is not encrypted? The reason is because even in the first and second first message, they have not decided which algorithm they are going to be use it. But after two messages, they have decided, okay, let's use dash or 3 dash or whatever. The question is why third and fourth message is not encrypted? The reason, we need a keying material. So do we have keying material? No. So this is the reason even after, immediately after the haggle, we are exchanging first word, keying material. The question why we have not exchanged keying material first, the reason in haggle we have decided which group I'm going to be using. This is the reason I have not exchanged there. So in this, the moment we have decided which group of Duby-Hellman I'm going to be used to exchange the keys, immediately we started the key exchange, and which is in third and fourth messages. Is that clear or not? Okay. So the moment we have exchanged the keying materials, now I'm ready for the encryption. So this is the reason fifth packet onwards is what? All the packets would be encrypted. Is that clear? So as you can see here, the fifth packet, this is about encrypted. This is the fourth message we have seen. Then fifth message, sixth is again encrypted. Seventh is again encrypted. Eighth is again encrypted. And last is again encrypted. All messages are encrypted. The reason, because we have exchanged keying material. Clear? Encrypted, it's fine, but why we are using fifth and sixth message? So fifth and sixth message we are using here for authentication. Is this for what? Authentication. Authentication, or you can say identification. What is that? Identification. Okay. In phase one, we have just decided which authentication method I'm going to be using. That is PSK, but we have not decided which is my key I'm going to be using. Or what is exactly the key? What is the password? Don't know. But we have decided earlier. So right now, before starting the data transfer or before starting the data encryption, now first we have to authenticate with each other. So this is the reason here. Authentication would be there in the fifth message. And here I'm sending my key. And that is what? Cisco. And along with that, I'm sending my identity. So what is my identity? 11.1.1. So the two information would be exchanged in your fifth packet. Identity is always unique. What is your name? Your name is your identity. That is always unique. What is the authentication key? That is Cisco. And who has decided? Network admin. Both the network admins has decided, let's use which key? Use the Cisco's key. Okay. And this information would be into the which format? This information would be always into the encrypted format. So this is the reason, because we have what? Keying material and everything. Clear? So this is about the which message? Fifth. And now sixth message is from the another side. And this is again same. It would carry the information. Key will remain same. But what is the identity? 15.1 here. And this is identities again. So out of three things, authentication, encryption, and hashing, authentication has been completed or not. And authentication would happen once. It's not after, it's not like with every packet it would happen. It's authenticated, so authenticated now. Okay. Authenticated for how long? Depends on the phase one. So if phase one is enabled for 24 hours, so authentication is valid for how many hours? 24. If the lifetime of your first phase is for the 20 hours, 10 hours, or whatever, authentication validity is equal to the lifetime of phase one. Keying material lifetime is equal to lifetime of phase one. Because in the phase one, what we are doing actually? Two things. One is key exchange and second is authentication. Authentication and, or you can say identification. Okay. This is not or, this is and actually. Or means one thing and means both the things. And this packet is, this message is also encrypted. And now if authentication has been done successfully, now my phase one is what? Phase one would be phase one is clear. And in case authentication failed, out of these three things, if anything would be failed, let's consider Haggle itself is failed, no communication further. Authentication failed, no communication further. Because now there would be error. What would be that? Authentication failed. What would be that? That would be authentication failed here. Does ASIC carry? Tunnel has been not up yet. Now phase one tunnel would be up here. Okay. Earlier, whatever the communication was there, that was over the ISP only, not via tunnel. Okay. This is the reason Diffie-Hellman they are using it, because that is the one of the securest key exchange method here. So in case if they are not using Diffie-Hellman, how would you exchange the keys? Okay. And if you would try to exchange the keys over the ISP, which is insecure, then hackers would be knows about your keys there, and then that concept wouldn't be secure. Clear or not? So this is now my phase one is up here. Let's talk about the phase two. See, very interesting concept here. Just try to understand. In Haggle, what I have decided. So now see, in the phase two, I'm going to be talk about the two things here. Encryption and hashing. Okay. So encryption means again encryption algorithm. In phase one, in Haggle, we have already decided, let's consider for encryption what we are using, 3-, and for hashing what we are going to be using, MD5. So this is we have decided just for phase one. Just for which phase? Phase one. In phase two, I have option key we can use two protocols. One is AH or ESP. ESP would provide encryption plus hashing, and AH would provide only what? Agree with this term? Let's consider I'm using ESP. So I have option for encryption and hashing. Now, next packet, 7th packet, from the which side? Initiator side. Okay. From the initiator side, here I'm going to be use ESP. So I have to mention here in ESP for encryption and for hashing, which algorithm I'm going to be use it here. You have option, you can use the same, the upper one which you are using, which is 3- or MD5. Or let's consider what I'm decided, you know, for encryption, this time I'll use bit advanced, which is AES, and here I'll use which one? Is that clear? So this message is all about, because this is my actual data tunnel. This is what? Data tunnel. And now same thing, and same thing is from the which packet? 7th packet. The first was the 7th, and then 8th, because now all the things are encrypted. Just note it down first, then I have to explain. First note it down, then I'll explain it.
There is no need match bit, same as above
Phase.
encryption and hash.
Yes, that is not needed. Okay, there is a it's up to you. If you want to use same, you can, but that is not mandatory. And the reason why I'm going to be use it separate, that I'll explain now. Okay, why I would prefer the separate one. Okay, just first mention it. They are going to be exchanged what again? Algorithm. Which one? Encryption or hashing. Authentication is not needed because authentication already has been completed in the phase 1. And that has been successfully done. This is the reason I'm inside the phase 2 now. In case if authentication failed, there's no possibility for the phase 2 because phase 2 is totally dependent on phase 1. This is clear? Now just think about it. Let's consider, see, as I'm saying, nothing is secure. I have already used this term earlier. What is that? Nothing is secure. Yeah, just see here, very important. Let's consider I have decided here. One more thing. Just 1 second. This is I have decided into phase 1. In the phase 1, we have decided we are going to use 3' and MD5 for encryption and hashing. But in second phase, so let's consider this is site A and this is like over the ISP and this is site B. Okay, you have sent the first message here, Haggle 1, and in that you have mentioned 3' and MD5. This is not encrypted. This is just in the clear text. There is a possibility might be hacker is sniffing your data and he is managed, like he is able to manage to sniff your data and he just got to know okay, what you are going to be used 3' and MD5. Is that clear or not? That as a hacker, this is in my mind. Okay, they are using what? 3' and MD5. After that, Diffie-Hellman done, and after that they have done authentication. Authentication happened successfully, but authentication happened in the encrypted format. That I don't know what exactly authentication key they are using it, and it's not possible for me to find out what exactly the authentication key. I have, let's consider I have their message or something, but this is in the encrypted format. I'll be not able to decrypt. I know which algorithm they are using it, but they are using which one? 3'. Because in the phase 1, we have encrypted the message with the help of the which one? 3'. But I'm not able or I could not decrypt it. The reason because I do not have keying material. I do not have what? Keying material. And what they have exchanged successfully. Okay. That is the combination of public, private, and all that we have discussed. We have mathematically we have discussed, but along with that, we have seen the option of the color options. If you would merge 2 colors and all, it's not possible for anyone to keep it separate again, right? So same thing. This is fine. But after that, the 6th and 7th message. So this guy is saying, no problem. I do not have any keying material, no problem. But now I know that data exchange, whatever would happen in phase 2, they are going to be exchanged what? 3' and MD5. So as a network admin for the safer side, first of all, as a network admin, I know that is not possible for the hacker to crack my keying material. But still, I'm saying for the safer side, they are also have the advanced algorithms and concepts. There might be, they would be able to manage for the phase 1. For my safer side, what I'll do it in the second phase, instead of using 3' and MD5, I'll negotiate on the different parameter. What is that? ASN, SHA. So now in my 7th and 8th message, we have decided again for data encryption, which would happen in the phase 2, which algorithm we would use? AES-N, SHA. So this guy is still thinking for data, what actually we the initiator and responder is using 3' or MD5. But actually what we are using it, we are using AES-N, SHA. They're totally different or not? So this is advanced concept. Clear? So this is the reason in the second phase, you have an option. You can use a different cryptographic method for encryption and hashing. So all Cisco's is also always recommended that in the phase 1 use different encryption and hashing, and in phase 2 use different encryption and hashing. Otherwise, it's your choice. If you're using same, that is also secure, because the phase 1 keying material has not been like, that is not, you can say the hacker is not aware about your keying material. That is also secure, but still for the safer side again, okay, it's better to use different algorithms, because this is you have negotiated into which format? Encrypted format. Is this clear? So this is a 7th message, this is 8th message, and 9th message is from this side, and this is again into which format? Encrypted. So this is, it's considered as a, this is what kind of acknowledgement. This is kind of what? As a acknowledgement. And now 9 messages exchanged successfully, and this is up. Phase 2 is also okay. And after that, there would be data exchange. As you can see, this is okay. I think data we have not exchanged into this. So you can see which protocol we have decided into phase 2. Up to here, 9 messages done. After that, first data packet. Which packet? The data. The what, let's consider I'm doing ping, I'm using telnet, HTTP, whatever. So it would be encrypted. Which protocol I'm using? ESP. Now it's not ISACAM. ISACAM is limited just for handshake. After that, in the phase 2, we have decided which protocol, ESP or AH here. So I have decided ESP, which would provide encryption plus hashing. So if you would open this message here, IP, and after that ESP encrypted, even with the help of this packet, you won't be able to identify actually, is this telnet or is this ping or is this HTTP or is this HTTP SOR? So what exactly that? No idea. But this is first packet. So this is the reason ESP sequence number is 1. Okay. So this is all about the encrypted packets. Okay. But AH won't provide any encryption. That would provide only hashing. So once this is, I have negotiated again something here. This is one of the packet here. And in that, I'm using authentication. This is the captures of AH. Previously, that was for ESP. And now this is for AH. But AH is saying, hey, I'm not going to be providing you any encryption. I'm just providing what? Hashing only. I'm saying, okay, that is sufficient, because internally I'm exchanging the data. Internally, I'm using some VPN, and I do not want any kind of encryption. I just want 2 basic security, authentication and hashing. Authentication means the data is, or the tunnel has been established between 2 authenticated devices or site of the persons. Okay. And after that, whatever the data you are exchanging, that has not been modified any third party in between here. This encryption is not needed. Okay. So many scenarios where encryption won't be needed here, because inside the corporate and inside my network, I believe my team. I have trust, but blindly I cannot trust. So that's the reason you can put what? Encryption also, but still I trust that. So that's the reason I'm using what? Authentication. So as you can see, as per authentication, if I'll compare it the previous message here, this is ESP. IP header we have, but after that ESP and everything is encrypted. No idea about that. But here you can see into AH, we have AH, and then we have one more header. Okay. And after that we have ICMP here, and ICMP means what? 8 and 0. So this is echo request. So here I can identify ki, yes, this is about what? Ping here. Is this clear? Okay. And this is that data. So this is into which format? Clear text. So authentication is not secure. Okay. Because the reason there is a no encryption. We need always which one? ESP. So ESP we are using here. So today we have seen these captures from the previous one. Okay. Because I have to show you along with this, but in the next class. So today we have discussed what exactly this is. So tomorrow we will start with configuration of this. Okay. Still we have 5 to 10 minutes. Let's see. So now Any doubt, any question in this one? So I'll just quick revision of all this. So this is phase one, message number one. Okay. So message one is all about haggle. This is all about haggle. And along with that, initiator SPI, and along with that, responder SPI. How it would calculate SPI? With the help of source IP, destination IP, source port, destination port, and time stamp over. Okay. Same from the another side, that is all again same haggle. Okay. Third and fourth message is all about Diffie-Hellman. Okay. So on the both the side, we would have what? King material. And then fifth and sixth message is all about what? First of all, it would be encrypted. And second, there would be authentication plus identification. Authentication is about the key. What key exactly we are using? Let's consider we are using Cisco. And this is the identity of the router. That is now 11.1.1. Clear or not? Second thing, sixth message is again from the another side. There would be again authentication key. This is again authentication key is what? Cisco. And what is the identity? That would be 15.1. Clear or not? So this is done. Now, after that, all the now onwards, all the packets are in the encrypted format. So then we have seventh and eighth packet. So this is all about ESP, and in ESP we have decided, and it's about encryption and hashing. So here I have decided AES and I have decided SHA, which is different from my phase one. Okay. Eighth message is same reply from the another side. Ninth is about acknowledgement, and now my tunnel is up here. So my phase one and phase two both are. Now we can exchange the data. And data would be into which format? Encrypted format. Clear? I'm done for the day. Any doubt, any questions? Anyone?
Sir, I have a doubt, sir.
Yes, please.
You told that first 6 messages are not secured because all the data is traveled via ISP.
I have not mentioned that first 6 messages are not secure. I have just mentioned that first 4 messages are into the cleared. But 5th and 6th is into the encrypted mode. Okay, encrypted and
Okay, sir.
hashed. Okay.
It
Yes.
uses ISP, right? To exchange initial messages.
Sorry.
So for message 1, message 2,
Hmm.
so whatever the policies that we have defined in ISAC MP
Hmm.
is carried from initiator to responder, right?
Right.
So that is traveled over via ISP, you said.
Yes.
So ISP is used as the overlay using the tunnel, sir?
See, in one message number 1, where we are talking about, we have not still, my tunnel is not up. We are going to be negotiate, and after that it would be configured, and then it would be overlay protocol. So right now ISP is just a underlay concept here. Okay. And when it would be underlay, once over your tunnel would be up. If your tunnel has not been established, so ISP is only the option we have. So if you don't have any overlay upper, if you don't have any option, how you can talk about the business? So ISP is the first reachability concept we have. So in the starting, you cannot use the term about underlay. When you can use the term about overlay and underlay, once your tunnel would be up. Let's consider you are at home, you have just a ground floor. You don't have first floor. So we cannot say at home, okay, we have 2 floors, first floor and second floor. One, we can talk about the ground or first floor. If it's there, then only, okay, ground, you have to go to the ground floor or the first floor. Then only, let's consider you have only ground floor itself. So do you think we are going to talk about any upper faces or upper floors? No, that is the normal concept. Okay. So in the starting, there is a no term, okay, about underlay. When this underlay would be comes in the role, once tunnel would be up. After that underlay, ISP would become under, and on top of that, what you are using it, that would become over. Is this clear now?
Yes, sir. Once the authentication is done, only then tunnel is used, right, sir?
Actually, after even phase 2. Okay, phase one means half of the tunnel you can say is upward. Okay, it's not been completed, or you can say it's in a two phases, the tunnel one and tunnel phase one and phase two. So once both the phases would be up, then your actual tunnel would be up here. If phase one is done, we cannot think about phase two because half of part is what? Disable only. Clear? And if your phase one is up, then only we can move to the phase two. So once your both the phases would be up, after that only your actual tunnel would be up there. There is a possibility might be you have issues with the phase two. In the ASP, on the one side I have mentioned AES, and on another side I have mentioned dash. So the phase two negotiation is not happening successfully. There is a possibility, right? So then phase two won't be up. And if phase two won't be, phase one is up, but phase two is still in the which state? Down state here. So it means your tunnel is not upright. Yes, Santosh, is this clear or not?
Yeah, yes,
No.
sir. Yes, sir. Clear.
Okay, so tunnel is equal to phase one plus phase two. Phase one is not equal to any tunnel here. You can just refer it, okay, this is for the tunnel one, which we're just going to be using. But actually, if you will talk about tunnel is equal to phase one plus phase two, and both the phases must be up, and that is equal to tunnel up here. Yes, any other doubt, any questions?
Sir,
Yes, please.
when only H is used, so you showed in Wireshark that only clear text is visible. So a hacker can read that clear text, sir.
Yes, and that's the reason we don't use it over the ISP. We always use what? Inside the network. Okay, where we need less security. So authentication header concept we won't use over the ISP.
What tools they use, sir, usually to find out what is that clear text is all about?
Sorry?
What kind of tool they use, sir, to see what exactly the plain text is?
Wireshark is there, and they have some other tools also. Okay, so that depends. So for that, so you have to get into the CH, how they do the actual hacking. Okay, so they have some other tools. Okay, Wireshark is one of them. One is the Splunk is also there. They use it, and might be they have so many other tools into that.
Got it.
Clear? Yes. What about other students? Any doubt? Any questions? Anyone? Physical, just be here. Online guys, any doubt? Any questions? Anyone? I hope all clear.
Sir, I have one more doubt, sir.
Yes, please.
So in tomorrow's class, we're going to discuss this aggressive mode plus quick mode, right?
Definitely not. That would be after a week. Because first we
Oh.
will learn how to configure it.
Sir, you mentioned that it is usually used within the LAN or the same network, right?
Yes.
So does it mean L2 VPN, sir?
No, that doesn't mean as an L2 VPN.
Okay, sir.
Okay. All clear now? So online guys, shall I close the meeting? Yeah, one
Yes.
guy was asking drive access. Sayyid Farooq, right? Sayyid, kindly share your email ID. Just now I have seen the message. Now the task for the day is GRE. Okay, and along with that, you have to go through all these 9 message exchange. Okay, so GRE, once you done with your practical, you have to share the screenshot in the group itself. Okay. Sayyid, are you there or you left? Sayyid Farooq, are you
Sir,
there?
I'm changing.
Yes, kindly text your email ID. Okay, physical gas handling. Okay. Got it. I'll share that drive. Okay, no problem, Karthik. I'll share it. Okay, I got your email ID. Okay, I'll just share it. Okay, guys. Then thank you and see you tomorrow. Bye bye.